Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Now we're going to give a viewpoint from Microsoft, and in particular Microsoft Live Labs. And this is, it's a pleasure to introduce Gary Flake for those of you who don't know him. We don't have time for a long introduction, so I'm going to cut it short and just say that Gary heads Microsoft Live Labs, and he's a technical fellow here at Microsoft, one among the very few. Thank you.
Thank you. It's a real pleasure to be here speaking in front of all the people who've been working on a lot of our data. This was, I don't know if all of you remember, but we released our data around the same time that AOL did, and so there was a little, just before, and there was quite a bit of a firestorm with AOL. I was the guy who signed off on releasing the data, so I didn't get fired, so that's good news, at least for me. So what I'm going to talk about today is some perspectives on where the future of web search can go. I thought it would be really interesting to take a bit of a 50,000-foot level over the industry and try to make some statements about where things look like they're going. And you may find this interesting or not. This is, I should have probably subtitled this, one jerk's opinion about this stuff. So it's very subjective, but I hope you find this interesting. So I'm going to start off with something that you've all probably heard of, this thing known as the parable of the blind man and the elephant. And it's a cute little story. Basically, you get a bunch of blind men looking at an elephant. They're only feeling part of it. One says it's a pipe, it's a branch, it's a pillar, it's a wall, it's a rope, it's a hand fan. I don't know how he got up there. But if you continue with the story, wise man says, well, what's really going on is you're only seeing part of it. And if you kind of rationalize and reconcile what each of you is sensing, you'll discover that there's actually something more bigger and profound going on. Namely, there's an elephant there. And my claim is that web search is a little bit like this, in that we have a bunch of different stakeholders in terms of who drives the evolution of the search industry. We have the business strategist, the end user, the research scientist, and this person says, money, money, money. This person over here says, I want to find stuff and get things done and have fun. And this person says, algorithms, algorithms, algorithms. So how do you actually rationalize how do you rationalize all that? And how do you, each of these different stakeholders say something quite different about what search means. This group would say it's about solving strong AI problems. It's about, disintermediating old media. They'll just say, again, I just want to have fun and get stuff done. And my whole point, and I've got to say, I'm not positioning myself as the wise man here. I'm positioning myself as a blind man who's been hitting a lot of walls and things, and I want to share my experiences with you. There may be a way of actually rationalizing all of these different viewpoints in such a way that if we can kind of reconcile, we may actually end up with something that's more meaningful than if we stick with the individual pieces. And so I hope to convince you after the end of this presentation that there is in fact reconciling these differences reveals something very powerful. So the outline for the talk is 3 possible futures for the future of web search: the business strategist view, the user value view, and the research, the view with respect to research programs. And then we'll conclude with looking at the patterns. So let's start with the business strategies. You don't need to read these little things, but in a nutshell, I'm going to make a case that web search as a business strategy looks like something that's sandwiched in between old industries and new industries. So let's start with that. I'm going to introduce some diagrams to explain relationships, and they're not very complicated, but I have a couple of different blocks and a couple of different connectors. I have circles are agents, squares are an object. And these little things here are little data side effects. So we say that A produces B. We say that A as an agent chooses B. So I'm introducing a notion of choice here. We say that A may indirectly or weakly choose B. And we say A produces this data set C as a side effect of some activity. All right? So with that sort of those basic atomic objects, here's something that is quite near and dear to Microsoft, the operating system ecosystem, if you will. And here in the center of the universe, we have this thing called an operating system. We are an OS provider. Users don't actually necessarily pick us. What they do is they pick a PC and programs that they want to run. Okay? It is the equipment manufacturers who actually pick the hardware and the OS that they want to target, and it is the software vendors who pick the OS and developer tools from which they want to produce programs. And so when you put all this together, there's just this really interesting codependency, and this is why we refer to this as an ecosystem. And if you're familiar with network effects and things like this, this isn't a direct network effect, it's an indirect network effect. So provided that all the different participants have some sort of relationship with the whole thing where each is adding some level of value, you know, the aggregate pool of value can grow as the size grows. A side effect here, which is really important, is individual user data. So in the evolution of the PC world, we had this ecosystem evolve, and people who use PCs produce data. It's pretty simple. Now, you work your way up the stack in some sense, and you say, okay, let's talk about the information ecosystem, which is something a little bit more nebulous because I would include everything from radio to television to offline, online publishing, a whole bunch of different things. But in general, you end up with some participants that are not unlike what we just saw before. Instead of having an OS where a lot of, which is something of the hub of that ecosystem, we have file formats, protocols, DRM, network pipes, network access. Those are the things that actually have a controlling influence. And so you have users that are actually, they're not really picking what their network is so much as what's the catalog or what's the specific content. And content producers and distributors and publishers and format owners play much the same role as the other participants in the previous slide. And it's interesting because, there's some different strengths and weaknesses, and we see that content producers are sometimes closely or indirectly aligned with distributors, as is the case in television, things like that. But it's not that different. A side effect here is usage of others' data. Okay? Previous side effect was my data. Now this is usage of others' data. Working our way down, we have the search ecosystem, which, again, looks like this. And today, this diagram might look a little bit weird, because why am I separating value-added experience from a cloud syndication platform? Because now all these things have been kind of aggregated, right? But remember, in the early days of search engine providers sometimes were just the secret sauce underneath the hood, like Inktomi, and even Google. Google's, front page was like, the way that they market it to buyers like Yahoo. Okay, they sold their services to Yahoo. And what has happened, as in the other industries, to get a competitive strength, the different participants have actually tried to, for lack of a better way of putting it, they've tried to bundle services and products together so that they can have competitive strength. So Google has bundled here, and others have bundled other things, and just like how Microsoft has, in some ways, bundled themselves in the role of being an OS producer and a software vendor, building a killer app like Office in order to give more value to the operating system and things like that. Google and we have done the same thing here. Advertising ecosystem, again, similar pattern. Oh, I should say, here, side effect is attention to a specific catalog or specific content. Going on to the advertising ecosystem, we have an ad platform that's like AdWords or Ad Center or Yahoo's, Panama thing. You have advertising affiliates. That's a destination site that they have content that they want to monetize. You have advertisers, and all these things kind of coming together, and you ultimately end up with consumer business intelligence as a side effect. Again, similar pattern. Finally, a payment ecosystem, where you have the platform, the card issuer, the merchant, the payment platform provider, the user, and again, users are picking a payment experience like I like a credit card. They're picking a product to buy from a merchant. The merchant is also picking a payment platform and the merchant services that go along with it, and so on and so forth. So we have an example of many different industries that have kind of creeped along, all exhibiting a very similar indirect network effect pattern where there typically is 3 to 4 different types of participants, each playing its role within the ecosystem. Now what gets really interesting is when you stack these things up next to each other, they start to look a lot like a technology stack, but now it's like a business strategy stack. So the computing ecosystem enables programs, has a byproduct of user-created objects. It's fundamentally about your stuff. The information ecosystem is about other people's stuff. Okay, how can I play a DVD? How can I listen to some music? How can I, access something over TCP/IP? The search ecosystem is about collections or catalogs of stuff, right? Now that we have a whole bunch of stuff, and I'm not just wanting to pick one item or another, but wanting to search over a library or a catalog that's vastly bigger than what I can ever scan over, that becomes an important thing. Advertising ecosystem is about attention to stuff. Okay, and the payment ecosystem is about purchasing stuff. So in a very real way, each of these layers, in some sense, builds off the other. It doesn't really make a whole lot of sense in an online setting without the previous thing. And in fact, this is kind of in the order that we've seen things evolve. Accepting here that we've had offline payment systems, of course, but now they're starting to mature, and I'll claim that they're starting to mature because we have advertising platforms now. So, I already made that point. Now, what gets really, really interesting, I think, from looking at the competitive landscape, thinking about where companies evolve, is that the lines are blurring. And so I'm going to abuse labels and words here for a moment and say, this computing information ecosystem used to look like two things, but really it's turning into an online-enabled application. You see things like Rightly here. What is Hotmail? Hotmail is an application and it's an information service. So, we see a blurring of things here. Information and search is really enabling something more general, like discovery. How do I find content that's more like, what I want to consume? And now we are, in fact, seeing search platforms combine publishing with discovery of new things. Everything from Gbase to our own Q&A product to Blogger to all these other things that are actually trying to, in fact, make a market of an information ecosystem and a discovery ecosystem. Search and advertising is becoming an online marketing system, and advertising and payments kind of combine to build this thing called fulfillment. When you put all these things together, we end up with something that I like to call an ecosystem of ecosystems, because now each is sort of fueling the other. We have the applications producing content, the content actually giving fuel to that which you might want to discover, the discovery yielding targeting information for marketing purposes, marketing yielding transaction, which fuels fulfillment, which generates revenue, which funds your applications. And so if you need but one crisp example of seeing how this kind of works out, just look at like Gmail. Okay? Gmail is an application with integrated search, with targeted advertising inside of it, and in fact, if you have the G Wallet, that's soup to nuts. They'll even kind of the next step is they loop you in on a loyalty program there for buying with them. So it's the trend in the industry is to actually close the loop in all this to make it one big ecosystem. So that's pretty neat. But now that's kind of my first part. Business strategy, some trends in the, what's going on in the business world. Let's now switch gears, take off our business hats, and now put on a user hat. I don't care about the money. I now want search to evolve in a way that's more consistent with me as a user. So I will claim, and this might be a contentious statement, that consumers have activity that roughly buckets into three different things. I consume, and I do that from search or browsing or shopping. I create, and that's in the form of simplified authoring and participation. And I connect, and that's sharing, communication, community, whatever. And maybe this isn't perfect, maybe it's not complete, but to a great extent, maybe 80 or 90% of what most people do falls into one of these three buckets, right? So let's just talk about these three things in sequence, just to kind of expand on them a little bit. By consumption, we have both search, the web, vertical, hidden web, paid, and shopping. There's all types of different types of browsing that are part of this paradigm, whether it's multimedia, music applications, iTunes. We now have videos and books and patents and journals that are all online. We have head content, tail content, user ratings, reviews, Amazon and other commerce. And then even things like recommendations and collaborative filtering and alerts and agents. So all of these are ways for information to find its way to us, how we consume. And search is just one thing. And one claim that I'll make is that in the future, the lines between what is clearly a search and what is a browse and what is a recommendation will all kind of blur a bit. It just should. Creation is, I think, really one of the things that has changed in the past 5 to 10 years, where the dynamics have now suddenly changed. Because it used to be that in a lot of areas, if you wanted to have an online presence, if you wanted to publish something, if you wanted to take lots of photos, all of these different things used to actually require substantial entry fees to get involved. And now the entry fees are like 0. Okay, so you could effectively be a creator of content that's either data or metadata, 0 entrance fee. All right, and this includes digital photography, video, blogging, podcasting, all these other different things. And even, I think it's incredibly exciting, academic publishing, where we're starting to disintermediate the old publishing industry. On the commerce side, if you want to think about creation as not just about publishing content, but also creating transactions, if you will. We have eBay, PayPal, YStores, Office Live, Amazon. All of these things are about democratizing the access to doing these sorts of things. And even on the development side, creating of new applications, we have web APIs, open source, software as a service, these things that are, again, taking the abstraction of, say, the complexity of a search engine and now turning it into a web API so that one developer who used to have to put a couple hundred man-years into having that sort of capability can now just reference it through an API. Really powerful stuff. Connections. We have the usual suspects: communication, community, social networking, document sharing, and this includes wikis, P2P, Google applications, and web-centric applications, folder share. There's a whole bunch of ways now that people are sharing, but it's all about connecting things, people and data. So when you put this together, there's yet another set of these cycles that kind of feed each other. So again, we find that enhanced modes of discovery, which is fundamentally about the acts of consumption, is really something that depends on there being lots of different types of creations because of the simplified authoring. That's where it really takes off. And the more stuff that people create means that there are more connections to be made and that there's new value in combining the data together, right? Which enhances how we go about discovering things, whether it's from collaborative filtering or from critical mass or other things that just speak to network effects and other things. So that's pretty exciting. But let's talk about a couple examples just so it's not just really abstract. Because I want to really make this point clear. Think about music for an example, as just one example. In music, it used to be that if you wanted to be part of a music ecosystem, you had to have a garage and musical instruments and friends to play with, and you had a garage band. Well, I can't play an instrument, which is kind of a painful regret in my life, but I certainly like listening to music, and I like consuming it, and I've found that, oddly enough, my playlist, a playlist of songs that I think somehow that are better together than apart, has been deemed a worthy object of sharing among people now, which is quite amazing because now we've lowered the barriers to participation in this ecosystem to something that someone as unskilled as myself can now be part of. That playlist becomes fuel for all sorts of recommendation and discovery engines for how do you help people find content that they'll like, or people that have similar tastes, or communities of people that they should interact with, or communities of musicians that they should be aware of, which is pretty powerful. That fuels the identity of new things that I might want to listen to, which fuels my drive to create more lists. So that's a very vertical example. And if you wanted to, you could pick just about any vertical on the web these days and find that it fits the same pattern. More telling, though, is that in a horizontal example like Wikipedia, not really topic specific, something general, we see the same kind of pattern, which is why I'll claim that Wikipedia went from 0 to surpassing in quality things like Encarta or Encyclopedia Britannica. And here we have more informed contributors who are creating and contributing and editing, more entries. That is creating not only just a bigger critical mass, but more value in the connections for how these different entries get wired together. And that's enhancing the breadth of depth of content, which is making this a more valuable thing from which to consume content from. So again, we have some more virtuous cycles. And there's a whole bunch of other things that we could say about that. Normally, when I give a variant of this talk and talking about, that there are in fact many new technologies that fit this patterns, I'd like to cite photosynth, which some of you may know is a project that began within MSR and University of Washington, and later kind of became a bit of a joint project with Live Labs, MSR, and University of Washington, and we've done a lot of interesting things with it. I don't have time to give a demo of photosynth if you haven't seen it, but one point that I want to make about it as a meta point, and I would encourage you to look at it yourself. It takes something like digital photography, where the network effects were a little bit more tenuous because they emerged from like tagging and things like that, and turn them from small network effects to huge network effects. Because what photosynth does is it takes a collection of digital photos and it teases out an entirely new data artifact, which we call a point cloud, that helps spatially locate how pictures relate to one another. So what it means is that when Suman puts his photos on the web, and I put my photos on the web, and we put them together, there's more value in the combination, much more nonlinear, highly, superlinear value than if we kept the two different collections apart. And so I think that's going to be a really important trend, because that's when you start seeing like these discontinuous jumps in the value or utility to end users and things. So now research programs, and now we're getting to the point where it's a bit near and dear to our heart. And now I'm thinking about what is important about the internet relative to a research scientist. So I decided in preparing this talk, let me just kind of make like a couple different buckets of research areas that are sort of web science-y, but not IR. I'm going to take IR off of it because IR is so obviously web science. I just want to talk about the things that are sort of, that are not as obviously web science, but kind of later on. So we have large graph analysis. We have collective intelligence, which is a label I made up. Okay, I admit there's no formal field of collective intelligence, but bear with me. Machine learning and data mining. And in each of these areas, I just enumerated a couple of different things that are clearly within that bucket. So we have graph sparsification, random walk type things like PageRank, like we just heard about in HITS. We have graph clustering. On collective intelligence, distributed games, collaborative filtering, prediction markets. This is all about taking big communities of independent things and seeing if there's some sort of emergent value. We have machine learning that has both entity feature extraction, spam detection, query recommendation, document classification, things like that. And data mining, you can think about it as either more, traditional or statistical, and, concept mining, anomaly detection, market basket analysis, trend analysis. Well, what's really interesting is that when you take these different disciplines, these areas have conferences that are siloed, okay? And some of them are combining things, but yeah, we have dedicated machine learning conferences. We have dedicated prediction market conferences that really, and they don't talk to the distributed games people. And we have, Fox and Stocks over here for this sort of thing, and over here this, KDD and different communities, all right? But what's really interesting is that there's kind of like these meta patterns that are coming out of these areas as applied to the web. Let's see what they are. I'll claim that we're seeing research areas somewhat collapse. And I'm going to, again, use very imperfect labels. But let's talk about 4 things: reduction, trust, similarity, and prediction. By reduction, I mean, how can I make a big space small? Wrap my hands around it. How can I ignore certain dimensions? And that's something that we see in a variety of forms. Trust. Is this object, agent, or event trustworthy? And that maps into anomaly detection, spam detection, fraud detection, those sorts of things. Similarity. Are these two things similar or not? Can I induce a metric space on them? Prediction. Can I forecast some sort of future event, time series, whatever, or can I classify some data with an unknown label? And interestingly enough, in a more abstract, pure form, you can think about this as matrix completion, not in the sense that is often used in hardcore applied mathematics, but more in the sense of I have a matrix, it has some question marks in it. How do I fill in the question marks? Collaborative filtering looks a lot like that and can be formalized in that way. So if we consider these sorts of hybrid, non-academic areas, but sort of research area themes, well, it's kind of interesting that, okay, reduction, where you have graph sparsification, concept mining, entity feature extraction, that kind of pops up within 3 different domains as kind of a major theme. Trust, random walk techniques on graphs, whether it's the page rank variant or topic sensitive page rank or hits or any of the other dozen flavors. Collective intelligence, trust over collective intelligence. That's the whole purpose behind distributed games. How can I make distributed games so that independent people are kind of co-validating one another? Spam detection is an obvious example of machine learning. And from data mining, anomaly detection. How do I find when there's something funky in the data? That it suggests fraud or a mistake or something else. Similarity, graph clustering. Which of these things are alike? Collaborative filtering under collective intelligence. Query recommendations under machine learning. Which of these queries are alike? Market basket analysis under data mining. So again, my claim is that, and there's going to be a reason why I'm kind of like teasing out a matrix, if you will, or another basis for projecting other research areas into a more normalized basis, is because I think that there are some really interesting patterns that emerge. Because if you think about my 4 basic operations of trust, reduction, prediction, and similarity, these turn out to be operators that we're kind of combining either within a domain or across domains. No, I'm sorry. Prediction, I left that off, but prediction markets, document classification, trend analysis. So, yeah, the reason why it's important is that within a single area, this pattern is becoming a theme of that people are using over and over and over again. And I had not seen the program, but that was a pattern that was cited in the last talk to a certain extent. And I'll talk about that as an example. But between areas, the core problems are starting to look a lot more like one another. And because of that, co-learning can now be used between them. So if we take an example, I want to semi-automate many document classifiers. One way that I would go about doing that is I would say, okay, let me take a similarity operation. How do I semi-supervise web page clustering? So I'll start off with a small number of labels, and how can I use that to bootstrap some clustering of some data? From those clusters, can I use them to actually tease out what are the features between classes that have the most information gain? All right, so now I've just provided a reduction set on a dual space, the feature space now. Prediction is use the feature space to build a classifier and apply to the unlabeled pages. The trust is prioritize human labeling with a classifier, taking almost an active learning framework to something. And then repeat with new labels for semi-supervised clustering. So within one problem domain, applying these almost as operators for how do you take a web problem and make it scale. In this particular instance, I put a human in the loop. Across domains, it gets even more interesting, and we heard talks about this just already today. So if you take document classes and click logs, well, you can use that with queries with clicks that tend to one class produce synthesized training data for query classifiers. Document classes plus the web graph, which we just saw, applied with PageRank propagates spam score yielding more training data for document class training. And now you can have two different modes for assessing the quality or reputation of something and using each to sort of co-validate or co-train one another. Query classes and query logs give you a little bit of a starting point for doing entity extraction over queries to tease out what are the important grams. So this is not just something that's sort of like I think a casual observation with respect to, okay, we have themes that are emerging in different areas. We see those themes as being almost like basic primitive operators as how they're used within a domain and across domains. But we're also seeing the data within the domains kind of collapsing as well. So if I just take 3 different clusterings of what type of data I'm used to seeing. Well, there's agents, and those could be users, or they could be businesses that are, advertisers or groups, just some sort of entity that has the ability of taking actions, okay, clicks, impressions, queries, or something else, on objects, which could be web pages, advertisements, multimedia, or whatever. And what is really interesting is that we've long understood the value of trying to figure out a metric space within one section of the triangle. Is this web page similar to this web page? And we do this by classifiers or clustering on terms, or maybe clustering on the web graph. We've done the same thing with actions. You take the bipartite graph of click logs to users or click logs to pages. You try to do clustering on that. And you try to figure out, okay, what queries tend to be the same or have some similarities? Britney Spears and Avril Lavigne, or whatever. You figure out things like that. And agents, we try to figure out, are you like this user, and use that as the basis of recommendation systems. And so in all these cases, we've rather explicitly teased out similarity metrics for saying when apples and apples are similar to each other, and when oranges and oranges are similar to each other. What we're now just beginning to do is to think about this idea that there could be something like a normalized, Rosetta Stone feature space in between that helps us translate between worlds. So for example, when can I say that this user has, and maybe similarity is not the right word. Maybe the right word is affinity. Maybe this user has affinity to this type of object. Or this user has affinity to this sort of query. Or this query has affinity to this sort of page. Well, that's a restatement of some really basic product objectives that we have, like web page relevance, or personalization, or a whole bunch of other things. And so my claim here is that, to a great extent, a lot of what web science, if I can abuse a term, is sort of converging to is something of an elegant collapsing of the different areas so that they can now start actually talking about the other's data sets. And that could be used in various ways to bootstrap the discovery of new patterns. And when you put all this together, and again, I'm kind of using the same pattern over and over again, we see web science research producing more and better algorithms that we put into practice. Those algorithms deployed, not just algorithms on textbooks or papers, but algorithms deployed, produce more and better data. The more and better data becomes the topic of new forms of data analysis, which gives more and better insights, which helps us to evolve our research to produce more and better algorithms. And again, I don't just mean one flavor of an algorithm, where you're making it a refinement. I mean algorithms and networks of algorithms where you have a better query classifier, a better web, better random walker type thing on the web graph, and a better document classifier, and each is sort of fueling the other, kind of bootstrapping. Getting a little bit bolder, I've talked before to some people in this room about something I call the internet singularity, and I'll call this one the Science Singularity, because of its resemblance to the one from science fiction. Scientific knowledge, our ability to make scientific statements, is really evolving in a very exciting way, because we're now starting to put scientific statements online. And I put engineering here as the bucket because the reason why we're able to put them online is we're starting to engineer big systems for holding scientific statements and data that supports scientific statements. So the Human Genome Project and the repository of publications that make references to gene sequences and those sorts of things. Well, that body of human knowledge being captured online allows us to start mining the literature about science as a first-order object for data mining. And that mathematical analysis allows us to search for discoveries in a semi-automated way, which fuels the collective pool of scientific knowledge. And this isn't just something that is sort of possibly happening. It is actually happening, especially in those domains that I cited before. In the In the biomedical world, NIH has set up these huge databases of gene sequences. They've set this up so that those who write papers about the gene sequences can now reference them in a standard way. You can now read a research paper and click from the gene sequence to more information about the gene sequence to seeing the papers that reference it and then traverse the citation graph. And what has happened is that there are now data miners who are mining that database of literature married to gene sequences. And because there's some degree of regularity and hypotheses and conclusions and conjectures that people make when they write papers, we've now gotten to the point where we're making medical discoveries via data mining of medical literature. So we've kind of gone up one level on the scientific stack in some sense. So back to the elephant. To recap, I've sort of put forth 3 different ways of thinking about web search that nominally, if you started off in the beginning, they look like very different ways of looking at the world. I want to make money. I want to have more fun and do more things. I want to do great research. They look like different things. And here was the restatement of them. What we're seeing, though, is that while each is something that is kind of fueling itself independently, they're also fueling one another. I think that we're really at one of the most interesting times in the history of computer science. Because it used to be, back in the 80s when I first started in AI, struggling to find the success story of getting some sort of a result in a product was a painful thing. And it was a hard thing to do, especially if that was how you justified your research budget. Today, we make improvements to algorithms, and you can demonstrably, you can with hardcore data say this is making tens of millions of dollars. And a refinement of an algorithm, or maybe even in some cases this is making $100 million. That kind of thing. And the reason why is that this business strategy of having data and the coupling between all of these data-fueled events, like transactions and information and search and discovery and marketing, is now, instead of being these things that happen in meat space, but now things that are instrumented as they occur on the web, it lends itself to basically funding more research programs that deal with those things, which create more value for the user, and the user here can also be the merchant, which in turn, that added utility is ultimately what drives the business strategy. So some interesting side notes on this. Just kind of recapping. What are the lessons, if you will? Well, data is gold. If you believe in this worldview, the long tail of everything matters more now. The long tail of content, the long tail of commerce, the long tail of queries, the long tail whatever. Because in many of these things within the internet, if they have a power law distribution, there's more data in that long tail than in the head. And it may just be that the merging trends that are most important for discovering what's new in research or what's new in business or what's new in user value happens first in that long tail. Network effects rule. And interestingly, it's not just a network effect within one localized thing now. It is networks of networks of networks. As we saw with web search having a network, which fueled a larger marketing network effect, of which search was just one component, and that from a business strategy fuels the network effects with respect to what it's doing with web science and the user value, and again, feeding the different business models. Finally, implicit in all of this is that there's something kind of like a hypothesize, experiment, feedback component to everything that we just talked about. Whether it was research or whether it was the user or even the business thing. And if you have done any studying of change as it happens in the physical world, thinking about things like the innovator's dilemma, what happens when there are industry shifts. What's fascinating is that the story for how disruption occurs in the offline world is something that could take decades to unfold. And in the online world, we now know, and I'm kind of like a first-hand victim of this, we now know that this process for very rapid change can lead to complete macroscopic industry changes of billions of dollars in very short windows of time. I say this because I'm going to take a moment just to give you a personal example so you know what I'm talking about. 2002, 2003, when I was at Overture, I was the chief science officer of Overture. And for those of you who don't know, that's the company that actually invented paid search and that advertising business model. And Google actually was relatively late to that. And at that time, we had more than double the revenue, double the advertisers, double the syndication partners than Google. And we had more money in the bank. We had an order of magnitude more money in the bank. We owned the internet. And there was no reason for us to believe, well, naively, that things would ever really change. And what was really kind of precarious about what we had done was that for paid search, which, again, just to remind you, is that it's when you type in a commercially oriented term and you see the sponsored links, there's an auction underneath the hood that generates those links. We had focused on the head of the query distribution because we used exact match technology, not approximate match. We focused on the head of the editorial distribution by using human editors to validate listings instead of using click-through rate statistics. We focused on the head of syndication partners like MSN and Yahoo instead of going to like a long tail of like AdSense. We focused on the head of merchants preferring to have high-touch relationships with big merchants as opposed to having a high-quality self-serve experience. And what Google did was a perfect playbook of beat by way of the innovator's dilemma by going to the long tail. They went to the tail of the query distribution. They went to the tail of the merchant population. They went to the tail of the syndication partners. And they went to the tail of listing quality using statistics instead of humans to improve their things. So 2002, we own the world. 2003, we see them up and coming or feeling nervous. 2004, we're neck and neck. 2005, game over. It was like that. And if you take a look at a similar sort of innovator's dilemma, say from the hardware industry, from Cray to Silicon Graphics to Sun to Dell to cell phones, that story is being unfolded even now after being played out over decades. So my claim is that when you have these network effects and these dynamics that are happening over data as opposed to physical events in the real world, things can happen much faster. So the main conclusion, going back to my metaphor of the blind man and the elephant, the whole point here is that the future of web search is not necessarily a function. Is necessarily a function of all the blind men. All right. The true story for where it will go, we'll have to actually say something about all three of those things. Normally, that would sound like a very complicated thing because they're completely different worlds, but I've hoped to convince you that, in fact, they're very similar worlds. It's just, you might have to think in a different way to see that. The future of each area is necessarily a function of the other two. So if you want to ask what is important from a business strategy perspective, think about what's important from research or what's important from the user value. You want to figure out what's going to really be the emergent things in user value? Think about the subtleties of the business strategy as well as research programs. If you want to figure out what research programs are actually going to have legs in the future, think about the business strategy and think about the user value. All of these things are feeding one another. So the real exciting news, and I almost, this is my final statement here, but I almost feel a need to, there's part of me, I have quite a bit of ambivalence right now because there's part of me that wants to maintain my credibility with you and not seem too over the top, but at the same time be honest with my feelings. Web business strategy is going to subsume the offline world. So if you ask, what is the future of that computing, information, discovery, marketing, fulfillment ecosystem, if it plays out its logical course, it should, in fact, subsume a $1 trillion industry that is now called Madison Avenue. If you take web usage and how it plays out, with not just being about search, but being about discovery of content in all of its forms, the production of content in all of its forms, and the network effect and new values that emerge from all of its form, well, that becomes a big story about what society evolves to. Because if that plays out, guess what? Academic publishers in the mainstream, they go away. The recording industry, they go away. A lot of things that we're used to that we accept as sort of part of the existing power base of society change. Web research, I'll claim, and this is really where I start sounding crazy, is I think it's going to subsume a lot of the non-web science. Because, and for the following reasons, I want to qualify this. I don't mean subsume in the way that it wipes out areas, but instead it takes areas that had formerly been maybe perceived as being less applied, and it now actually gives them a place where they can have huge, tremendous impact. So think about some of the really pure theoretic, like I have some friends who work on things like property testing over large databases, and and it's all theoretical, and they don't really have too much. A few years back they had no real desire or inkling that it would be tested on big things, but now that suddenly turns out to be a theory area that had tremendous applicability. And similarly, if you take a look at really what some of the big aspirations are for web search, it's not unlike some of the big challenge problems that we've all been thinking either explicitly or implicitly about strong AI, or about the future of computing, or distributed computing, or about the future of huge database systems. And in some sense, web search generalized in this way kind of captures some of the hardest aspects of the applied research, computer science research problems that we've ever really tackled. So with that, I thank you. Hey, I gotta give myself a pat on the back. This is the first time I've ever given this talk. I ended almost exactly on time, so I just I'm stunned myself. Okay, yeah, Ken.
Yeah. So
yeah.
Yeah. So we've I mean, you're making a compelling case that we live in exciting times. Next week, many of us are going to SIG-IR, and SIG-IR, I believe, is about to close registrations if they haven't done so already. It's sort of unprecedented. And so, all kinds of things are happening that that's sort of hard to deny. That said, for the last 2 days, the faculty summit's been struggling with the reality that freshman enrollments are at an all-time low.
Yeah.
Maybe what I hear is we've bottomed out and we're on the way back. But how do you reconcile that reality? And then another thing that's sort of going on here is, how do we convey this excitement that you're feeling the business excitement, other people are feeling the research excitement? Somehow people are saying it's because the problem is the first course we offer freshmen is just not very compelling. We don't even believe in it.
Yeah.
And now you were maybe arguing a different curriculum here.
I'm actually and this is a great question, by the way, and I really appreciate it. I have complex thoughts about this particular thing, because I actually think that there are probably 3 different computing-oriented career tracks that are justified. And I'm going to forget about some of the more engineering-focused ones like electrical engineering. I'm not even including that. I'm talking about fundamentally branching out, or let me tease them apart. I think that there has to be a place for traditional computer science, which might have, that might have the curriculum that people find boring. But if you think about this as the track that people go to actually be academics, to actually study. I'm reminded. What's that? Well, let me put it this way. Dijkstra said computer science is no more about computers than astronomy is about telescopes. And that's a rather extreme view of it, but I think that there still has to be a variant of computer science, whatever we call it. I think maybe putting science in the name was not the wisest thing to do.
Well, I was going to complain about web science.
Yeah, I know. And whenever you put science in the name, the first complaint is, well, that means it's not a science. Yeah. I think there's a necessity for the sake of the quality and caliber of our field from almost from a mathematical and scientific perspective of having something that's more like the pure science route to it. I also think the reality of the business world is that there's a curriculum that's appropriate for practitioners. And that is actually the biggest number of complaints that we get, that I'm taking these theory courses. I don't even need to know really what, forget recursion theory. I don't even need to know what really NP hard and NP completeness the difference is. I just know I got to stay away. Don't go there. Just give me a damn map and it says here no man enters or something like that, and teach me Java and teach me Perl and teach me to be a practitioner. And that, is something that some schools are taking up, and sometimes that is called computer information science or computer information systems or information. It goes by different names, but I think having a standard schema is important. Let me propose a third type of career track or academic track that borders on something that is often called informatics. And that is the intersection between computer science and other forms of the physical sciences. So think about what's going on in everything from bioinformatics, quantum computing, the intersection of computer science and some social sciences, where we're actually making social science into a real empirical science for, not for the first time, but in a very real way. And I think that this more of a informatic approach of taking the physical world and viewing it through the lens of a computer science set of methodologies is a very powerful one. I don't know that I answered the question, because I don't know that this is actually a solution. Maybe I'm just reflecting my biases. But clearly, having a curriculum where, my first year I had to code in JCL on punch cards. Okay.
I did that too, except not JCL.
Yeah. So, I don't know. Clearly, we had to change some things, and I think maybe just splitting it out so that those who actually want the focus math versus the application versus the connection to science is more appropriate.
Hi, Gary. One of the research areas that I consider a really important part of web science that was sort of missing from your slide is HCI.
True.
And I've noticed in the talks today that one of the most common things that people say they want is information about the user.
Yeah.
And I know you have the user kind of as a circle in your loop, but I was wondering if you think that there isn't perhaps a more central role.
You are correct that I was negligent in not giving that a more prominent role in this talk, and that's something that I'll consider to try to work into it. In fact, now that I think of it, so Stephen Drucker's on my team, and we, I probably invest in designers and HCI people in my team. I think that is much more traditional than what is found in Microsoft. I think that, and I think it's also interesting that there's some really interesting things going on in HCI where we're doing things like having HCI systems almost take abstract ideas like how do you make active learning something that's much more greater utility for users and better for producing valuable data, but really coupling to the interface that makes it possible. Turns out oftentimes the HCI questions are like the missing link for taking a failed effort and making it successful. So I didn't do a good job of including HCI there, but it is something that I've invested in myself. So.
Hi. So part of your convergence argument seems to suggest that the dependence of research agenda on business agenda will only increase. Is that a concern to you?
I would consider it a great thing, and here's why. It's bidirectional. And the greatest opportunity is for computer science to be the tail that wags the dog. I think actually, and I'll make a rather bold statement. I think the industry and this company and other companies have much more need to take from some of the ideas that we have than the other way around. Now, there's going to be a mutual informing of one another where the priorities kind of shift a little bit. Like, for example, If someone tells you, you know, we've got this great thing, the whole problem is it has a huge surface area for fraud and manipulation. And if we could only crack that nut, it goes from being a dead on arrival business model to being something that could be game-changing. Now suddenly, and one way for that to happen is if the business people come to you and say, we got this great thing, but it's just lacking this sort of trust thing in order to really make it work out, or this authority or reputation thing to make it work out. Another way of kind of turning that upside down is for the computer scientists to actually think about the business models in which trust and authority and reputation were the missing links from making them viable. Because oftentimes we know more about the landscape in terms of if you think about it this way, business models are like recipes. They have ingredients. And the chef only knows about ingredients that are within their realm of experience. Most people who work on business strategy don't know really in a good gut sense where machine learning is going to make a difference here, or trust and reputation algorithms are going to have an impact here. But we do, and I would claim that we'll actually have an easier time figuring out the subtleties of how do you make successful business models and leveraging known research projects to make them better. So I think it's actually great news for us. I want to follow up with a personal thing. I considered myself a student of failed R&D funding models for over a decade. I was at Siemens Corporate Research, and then it kind of like died, and NEC Research Institute, and then it kind of died. And so I was collecting, I was like jumping off as they were sinking. And I started working as the chief scientist of Overture. Yeah, I'm here now. Hey, I'm going to tell you a success story. Okay? Yeah, that's right. Yeah, I leave a wake of destruction. I went to Overture, and for the first time I actually got to create an interesting research group, from scratch. And I positioned it so that I got to be part of the executive team, not just like working for an executive. And what happened was one of the earliest projects we did was we took some techniques from bioinformatics on approximate string matching and for gene sequences and bioinformatics, and applying the same techniques for basically coming up with weighted edit distance that was derived from empirical data, and we applied it on query logs. And what we were able to do, and here's the thing. Overture did not know how to deploy a spell corrector, because every time they took an off-the-shelf spell corrector, it either had produced matches that the editorial team deemed to be unacceptably poor, or it had no impact. And what we did was we produced a spell corrector that broadened the number of queries that were matched, but was imperceivable from an editorial point of view in terms of the quality of the matches. And when we measured what the revenue impact was, because we had a matching engine, some of the traffic went into this spell corrector. We made matches that were otherwise not matched, and then they were served pages, and then there were click-throughs, and then money changed hands. And it turned out that we made $50 million for the company with this one project. So on that project, in a small company like Overture, I was like, okay, I've now justified my research budget for the next couple of years, and I made a point of with the executive team of making it so that conversation didn't have to happen anymore in terms of justifying it, and instead it changed it to how can we take research results and change the business models. So I think it was a really healthy shift.
Hi, Dale Hunter from University of Michigan.
Hi.
Really happy that you mentioned informatics, because that's what I do. I'm not a bioinformatician, but biomedical informatics.
Yeah.
And I totally agree that I think that's one of the kind of growth areas where all these things, these synergies you're talking about, are coming together. I have a couple things. One is that I think the death of computer science in the United States is probably overestimated. I was thinking about the history of science and engineering. You go back to the 1800s, you have mechanical engineering and chemistry are king. And then come the 1900s, in the first half or a little more of the century, materials science is there.
Yeah.
Mechanical engineering in chemistry are still there, but they're now subsidiary to this.
Yeah.
Then electronics comes into play, and computer science. They dominate the last half of the 20th century, and now they're becoming components, along with material science, mechanical engineering, and so on, in what I would say is we're at the dawn of information science, which brings together the study of knowledge itself and human-computer interface. I think computers are disappearing. When you look at the Surface machine, that's a premonition or a precursor of what's to come. Our clothing is going to start to talk to us in another 5 years. We're going to have newspapers that update themselves, minute by minute. So I think we're at a really exciting time. The one question I have about this, which is, this is because I'm old, I guess. I've seen a lot of this stuff come and go, and I've watched my children grow up through this. And I think that watching the children is really key, because my children's generation were the ones who discovered that communications were really computers were really tools for communication and not computing devices. So they've changed, though. I mean, over the years, and computers have changed them. It's been a kind of a co-evolutionary process.
How old are your kids?
They're in their early 20s now. So I consider them part of your generation, quite frankly.
You're being kind. I could be your children's parent.
Well, close enough, but I could probably still be your parent.
I don't think so.
Well, we'll see. We can have that discussion over beer later.
I'll be 40 in a couple of weeks. So.
Okay. Well, I'm about to turn 60. Actually, I just turned 50.
All right, you got me. All right. Okay.
Where I went to high school.
We'll do the blood test afterwards, okay? All right.
The one other question that I had that I will leave you with is, in medicine, like what has happened in recent years, I work in the clinical research area. One of the things that has become very big is the study of outcomes. In pharma, you have the resurgence or the surgence, I guess. I don't know if there was ever anything to read. Phase 4 clinical trials, where you're starting to watch what happens to people after you manage to push the drug out on the market. We're doing that kind of outcomes research on surgery techniques and chemotherapy and so on. And I'm wondering, to what degree is Microsoft investing in outcomes research, like looking at what all this is doing to society?
So, if I understand that correctly, boy, that's a complicated area, because I would say a broader way of stating what you just said was we're effectively starting to instrument reality.
Yes.
And I mean, a very substantial way where important events like, for example, this individual is a patient with this disease, and they're receiving this protocol of treatment, and we're observing these properties emerging over periods of time. Let's factor out the scary privacy issues for a second, because there's a lot of them, and I don't know quite how we solve them. One thing that I get tremendously excited about is if we do get beyond some of these data access and privacy issues, there could in fact be a new generation of outcome analysis, of data mining on reality, on these events that we formerly had no way of really tracking. And there's a parallel thing happening with how web businesses are evolving. It used to be that some people were saving the impression logs and the click logs and things like that, and cookies were our way of tracking these things. And then companies would slowly build out infrastructure to kind of actually literally store all the events, and then they didn't know what to do with the events, but now they're starting to aggregate statistics over time and over different segments and doing other things, and now it's turning into consumer intelligence and business intelligence. So we're slowly getting a little bit better. We're only now getting to the point where and we're not even doing this in the way that I think we should. You could almost start to represent a lot of, let's take a look at like a web business, tracking all of the long-term behaviors of an individual and trying to figure out how do you assign credit. So if you have a positive outcome, they buy things or they use many products or something like that, or they look at advertising, how do you actually assign credit to all the different things that you did? And that's kind of like the online variant. It's not quite the Bohr atom, but the fruit fly version of what you just said in some sense. And I think there's going to be talking about where theory and other areas could suddenly have tremendous application. Think about expressing what I just did as a reinforcement learning problem. I mean, it's a classic reinforcement learning problem. I have something that goes through a whole bunch of different states. There is, bing, some sort of credit assignment happens in one place, and I have to figure out how to pass the credit along. Now, we're not at the point where we can rationally solve that for commercial websites very well. We can do it a little bit, all right? And we're better than random, okay? But I'm really excited about the idea that practicing on a commerce site is in many ways the sort of baby steps to being able to do that on the aggregate medical records of the world. We can almost synthesize virtual pilot studies and segment different patient populations into different groups and do a historical analysis and actually articulate hypotheses as to where they'll go in the future and almost run virtual experiments in this way without actually changing too much. That's both terrifying and exciting. So who knows?
Okay, we're taking the very last question.
This is not a question, this is actually a comment. Microsoft is going to invest a lot of energy in something called e-science. And this is the joint between computer scientists and scientists from other areas. And there's going to be, in fact, a workshop on e-science at the University of North Carolina in Raleigh in October. If you give me your card, I can probably send you an invitation to that event.
All right.
All right.
Thank you very much.
Thank you very much.